All right. Good morning. Am I just imagining it? Do I really have 57 people in this class? It must be Friday. Thank you for being here today. How you guys doing? No, I'm not going to allow that. Well, welcome to Psychobiology. Thanks for being here. I am going to talk about our next chapter here. You know what? This is chapter 13. We have an exam next week covering 10 through 13. So I'm not going to, it doesn't look like I'm going to fall for that thing that I did the last two exams where I was like, oh, we have an exam this week. Sorry. And then I didn't get to the last chapter. So we're on track. And that's probably thanks to the feedback that you guys gave me. So thank you for suggesting that I do what I'm doing. So yeah, we're on track. We'll cover this on Monday and Wednesday next week as well. And any other review that you need for the exam. And like always, we'll take next Friday off. Is next Friday already Veterans Day anyway? So I'm not giving you the day off. It's not me. That's not fair. I'm not getting credit for giving you guys that Friday off. We have Veterans Day off anyway. Oh, well, I thought of it first. Okay, it was my plan. So, all right. Now, I would have loved to have talked more about the last chapter, especially patient HM. So I'm kind of glad I did squirt some of that in the first week or two. So that's quite honestly my favorite part of that chapter. And I zipped through it with 2 minutes at the end of last class. And I was like, damn it, I like talking about HM. And students like talking about HM. So if you have any desire to talk about his case with me, I know a lot about it. And I will enjoy talking to you about that. So just hit me up if you want to talk after class today or any day after class about patient HM. All right. So this chapter in this edition of the book, which doesn't matter to anybody, but it's been renamed. It used to have a god awful title, Lateralization. It had a lot of it was a mile-long chapter name. They just renamed it Cognitive Neuroscience. And so it does cover a lot of things, but it seems to be one of the shorter chapters. So there's that. All right. So there's a lot of things that we're going to cover, and we have a cognition and learning class, and I know some of you took that already, and some of you are going to take it, and so some of you already know exactly what's covered in cognitive classes, but we've covered things like attention, perception, and learning and memory, which we just divvied up into the previous chapter. But we're going to talk in this chapter about laterality. So the different functions that seem to be ascribed to the two hemispheres and cortex in the brain. We're going to cover language and intelligence and decision making. And if I have time on probably Wednesday, I think I'll share with you some animal research on intelligence and language in animals. All right. So there's just a little tiny bit of that in the textbook. They do make reference to one of the sets of studies that I'd love to share with you. You'll learn next week. I got kind of a little bit of an inside scoop on some bonobo research that's been done with the rock star Kanzi. How many of you have heard of Kanzi, the bonobo? Right, it's from my class. Okay, so I covered my intro class too. So we'll take there's a photo of Kanzi in your book, and they just barely make mention, and they talk about chimpanzees and not really bonobo chimps. So anyway, I'll share with you that research on and a little bit more on Wednesday of next week. So, but now today we're going to probably just look at laterality. So as you probably well know by now, even though we're quite symmetrical, and for just about every structure in our body, we've got a left and a right version of it, except for one part in the brain. Who can tell me one part in the brain that does not have a left or right part, but just one? Yeah. Well, it's got good guess because it's a nice central structure. But we do break, it's got a left and a right half, and so that one is split into two. It's an asymmetrical structure. Good guess though. And my next guess would be, if I was guessing and I didn't know the answer, that would lead me to the pituitary gland, and I'd be like, oh, the pituitary gland. There's only one of those, and so I'll add that to the list. There really is only one, and we don't really divide that up into left and half. Front and back we do. So I'm going to amend my question. That's one of two. So I'll give you a hint. Descartes seemed to have missed the pituitary gland. The pituitary gland, by the way, was super easy to miss. And that took a while to discover the pituitary gland, because it's such a fragile little structure, just dangling from a tiny stalk. And when they did dissections and stuff, it was almost assured that was going to get lost in the destruction. So I'm guessing it took a while to discover the pituitary gland. So what did Descartes say was the seat of the soul, because there was only one of them? This is like the third time I've asked you guys this trivia question. You don't get to answer because I can tell you know the answer. Say it out loud. I'll get you started. It's the blank gland and not the pituitary. Yeah, you can say it out loud because nobody's cooperating with me this morning. Good. The pineal gland. All right. So anyway, for the most part, everything has got a left and a right version, and it's quite symmetrical, but there's not, but we're also asymmetrical. All right. So lateralization, especially when we look at some functions, there are some distinct-ish differences, and then there's some that have kind of a mythological treatment to them that it's been exaggerated. All right, so I'll just mention this in passing. The book opens with this interesting case, of this child. This is the MRI of that child's brain, and and after a surgery, it was they had to remove the right half, almost the entire right half of this child's brain, and after just a month of physical therapy, this 9-year-old walked out of the hospital with a limp, and still some hopes. And I don't know if they became a ballerina, but still, so someone was asking me about plasticity in the brain the other day. And yes, of course, children, if somebody came along and removed your right hemisphere right now, it would take you a bit more than a month to do physical therapy to recover from that. And I don't think you would bounce back quite the same as a child can and did. So anyway, there are some amazing examples out there. This is just one. It's not like this was this is rare, but it's not a unique condition. No, we did learn a lot about this in an earlier chapter. So I did cover, and I'm not going to go over this again too much, but I'll just remind you of what we learned about the left and the right hemispheres, largely coming from some early studies done with the so-called split brain patients. Big handful of people that have had that surgical procedure done to sever that corpus callosum. How's that project on there? Not too bad. You can see it. I like that image. All right. So to remind you, the corpus callosum is a band of axons communicating information between the two cortex hemispheres. There's also an anterior commissure that's buried down below it. That's also connecting sort of the bottom halves of cortex. But this is a big beefy structure that connects the majority of the two hemispheres. And so in extreme cases of epilepsy, they have gone in and just severed those tracks. And it results in what they then call a split brain patient. So that a lot of students, when they hear that, without not knowing better, they think like the brain's been cut in half. And just you guys know by now, if you were to cut the entire brain in half, that would immediately kill a person. So we don't literally make them a split brain patient. Yeah, we learned that we saw that video with Joe, the split brain patient, right? We did that in class and we talked about that. I had you guys do the belly rub and the head tap, and you guys learned very well that you probably have an intact corpus callosum that prevents you from doing those kinds of two motor tasks with your left and your right hand, because the two sides are telling each other what they're doing, and that causes interference. But you saw Joe was quite able to do those kinds of tasks, and you learned some other interesting things. So I'll just kind of remind you some of the things that we learned about his case. So again, there's that anterior commissure down, below, connecting mainly the temporal lobes. So I love this image too. So a diffuser tensor image, that can help light up some of the tracks in the brain too. It's a really neat way to show pathways in the brain. So there's a neat image of the corpus callosum. So I got too many slides about that, so you get the idea now. So we watched this video. We're not going to watch it again now, and so I encourage you to watch it again because hey, I've watched it at least probably 500 times, and I am still just about as awed as probably even more awed as I was the first time, because I kept learning new things after watching it a few times. Like I picked up that little thing I told you about when he whispers the word stool to himself to help him, to help the hand from the, being controlled by the side of the brain that didn't see the word stool. He had to tell the other half of his brain what it saw, so that its hand could draw that image. So little things like that, it's like when I, watched that for like the 300th time, I was like, oh my God, this video is even cooler than I thought. So give that another look. And yeah, so we learned like the simple things, just that he seems to have largely that he's unaffected by this on his daily life. Only during these kind of artificial tasks, when he's directing his focus straight ahead, can they flash things that go to just one hemisphere or the other. And we learned that okay, language is usually housed on one side of the brain for most of us, and we're going to talk about that a little bit more in detail coming up. Jump into one of the last interesting things that we learned in that video was they showed him those images made up of this artist, Archon Baldo, has all these paintings that he's made of goofy kind of faces made up of different kind of objects. This one looks like it's made of, I can't tell from here, books or fruits and vegetables, and one I think was made out of different kinds of bread. When they projected that to one hemisphere or the other, revealed that the left hemisphere really seemed to be emphasizing the stuff that it's made up of. That so-called logical side of our brain would recognize the objects in the image and not the face. And the right hemisphere, when it's projected to the right hemisphere, he would report that he saw it as a face. Okay, Jamie.
Have they ever done people like this?
Oh, absolutely. They've done everything, MRI scans, certainly EEG and PET scan and probably diffuser tensor. Just, yeah, these people are, they have been studied intensely. Gazzaniga is still doing this. Gazzaniga was the guy. This video is from the 90s. And I can't remember if I told you or not, when I went to see Jacopo Annesi in his lab in San Diego, we went next door to the La Jolla Institute and saw there was a neuroscience convention that just happened to be going on. I was like, well, smoke, cool. And I happened to hear Gazzaniga give a talk, and this is 2010 or 12 or something like that. And guess what he talked about? Split brain phenomenon. So, and he was considerably older, okay? And now he's considerably older than he was in 2011. And so, anyway, so, this has been studied to death. All right, just to quickly remind you about the architecture of that also, that I did explain back then, and I hope you remember that this isn't the simple matter of the left eye is being processed by the right visual cortex and vice versa for the right eye and the left. It's the left visual field and the right visual field from both eyes. Half of the information in each eye stays on its side and half of it crosses over. So the net result is that the right visual field when a person is looking straight ahead goes only to the left hemisphere, and the left visual field goes only to the right. But then you and I with a normal corpus callosum, that information immediately screams over the other side, and it's just, both sides know everything. But not in Joe. All right, so yeah, we already learned all this about that kind of stuff. All right, I think I mentioned this, and I'm going to show you this. This is a terrible quality video that I'm going to show you, but it's pretty interesting. It's, I think, interesting. So your book doesn't mention this thing called the Wada test. It's named for a physician. I think he's a physician named, I think, Jun Wada, Korean, I believe. He I don't know if he was the first to discover this, but the thing is named after him. So it's this procedure where they inject it's like a barbiturate or an anesthetic or a depressant drug into one artery on one side of the neck or the other, and those arteries only feed their corresponding side of the hemisphere of cortex. And so they can apparently kind of shut down the majority of one hemisphere and not the other while the person's awake and everything. And then, by just interviewing them, talking to them, or observing them, you can just see what the effect is on this. All right. So let me show you the video of him doing this to a person. So I give this little heebie-jeebie warning just because it's, I don't know. I mean, there's, it's not, I've shown you worse. I don't know why. I just thought I sometimes fail to give you like a warning, like, hey, I'm about to show you something really gruesome. So I don't think this is gruesome, but it just shows, them injecting they're doing an injection, and it's like not even like it's connected to a hole that's going into the person. So it's nothing. I don't know. I sometimes think. Anyway, I'm done warning you. So do what you need to do if this bothers you. What's going to bother you most is the quality of the video. So sorry about that. I got no control.
6, 7, 8, 9, 10.
In almost all of us, language is processed in the left hemisphere.
This is okay. Show me how you can wiggle your fingers. Keep on wiggling.
In this test, in which the patient feels little discomfort, Jun Wada of the University of British Columbia first injects a dye opaque to X-rays into the artery supplying blood to the left hemisphere. This shows the route an anesthetic will follow when it is injected during the test.
That's almost impossible.
A similar series of X-rays, seen from above, shows how the dye, and hence the anesthetic, will flow only into the left hemisphere. It is vital the surgeon confirm where speech is located in each patient, so that an intended operation to alleviate epilepsy can be safely performed. The test also shows that the left hemisphere controls the right hand.
Start wiggling. Now I'd like you to count slow and loud to 10 and back to 1.
1,
Okay? Don't stop counting.
2, 3, 4, 5, 6, 7, 8.
The left hand remains upright, controlled by the still conscious right hemisphere.
Carry on.
Carry on. Okay. Carry on counting for us.
Speech gradually returns as the anesthetic clears the left hemisphere.
1.
Yeah, you did very well.
What we are trying to do here is to find out which side of the brain, which side these patients have speech function. And these knowledges are very important for us when we are contemplating of operating these patients.
Although 95% of the population has speech in the left hemisphere, there are exceptions. And for this reason, it is necessary to map the geography of each patient's brain to avoid interfering during surgery with such vital functions as speech and short-term memory. In a second test, a week later, the right hemisphere is anesthetized.
Matthew, could you start wiggling your fingers? Keep on wiggling, and look straight ahead. You don't have to look at me. Look straight ahead. Okay? Now start counting loud and slow.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10, 9, 8.
The conscious left hemisphere has retained speech.
5, 4,
Great.
3,
Okay, could you show the object?
Okay. Tell me what that is.
Last problem.
Right side, make a fist.
But the anesthetic in the right hemisphere causes disoriented movements of the opposing hand.
None at all? Show me how you can wiggle your fingers. What number did we show you?
8, 3, and 1.
8, 3, and 1. That's terrific.
And they didn't do the object recognition test with the other side, so I don't know what that would have revealed. But so anyway, the quality of that video is to be desired. But isn't that kind of cool? I mean, that's just kind of yeah. I don't know. I think it's cool. All right, so I want to take the time to watch this in class because
I grew up to study the
was it? Yes. Quick. I can do attendance. Yes. Queued up. So I'll start that in just a moment. All right. How many of you already seen this TED Talk? Okay, good handful of you. Once again, I hope you don't mind watching it again. I've watched it a few hundred times probably, and it still gives me the wows every time. So I don't need to give it any kind of introduction there. She's going to introduce herself and tell you who she is and why she's talking to you. So I know you will enjoy this talk, and I like that we'll have a little bit of time to discuss it afterwards this time. So here we go, and I'll start the attendance.
the brain because I have a brother who has been diagnosed with a brain disorder, schizophrenia. And as a sister and later as a scientist, I wanted to understand why is it that I can take my dreams, I can connect them to my reality, and I can make my dreams come true. What is it about my brother's brain and his schizophrenia that he cannot connect his dreams to a common and shared reality, so they instead become delusion? So I dedicated my career to research into the severe mental illnesses. And I moved from my home state of Indiana to Boston, where I was working in the lab of Dr. Francine Bennis in the Harvard Department of Psychiatry. And in the lab, we were asking the question, what are the biological differences between the brains of individuals who would be diagnosed as normal control as compared with the brains of individuals diagnosed with schizophrenia, schizoaffective, or bipolar disorder? So we were essentially mapping the microcircuitry of the brain, which cells are communicating with which cells, with which chemicals, and then in what quantities of those chemicals. So there was a lot of meaning in my life because I was performing this type of research during the day, but then in the evenings and on the weekends, I traveled as an advocate for NAMI, the National Alliance on Mental Illness. But on the morning of December 10, 1996, I woke up to discover that I had a brain disorder of my own. A blood vessel exploded in the left half of my brain. And in the course of 4 hours, I watched my brain completely deteriorate in its ability to process all information. On the morning of the hemorrhage, I could not walk, talk, read, write, or recall any of my life. I essentially became an infant in a woman's body. If you've ever seen a human brain, it's obvious that the two hemispheres are completely separate from one another. And I have brought for you a real human brain. Thank you. So this is a real human brain. This is the front of the brain, the back of the brain with the spinal cord hanging down. And this is how it would be positioned inside of my head. And when you look at the brain, it's obvious that the two cerebral cortices are completely separate from one another. For those of you who understand computers, our right hemisphere functions like a parallel processor, while our left hemisphere functions like a serial processor. The two hemispheres do communicate with one another through the corpus callosum, which is made up of some 300 million axonal fibers. But other than that, the two hemispheres are completely separate. Because they process information differently, each of our hemispheres think about different things, they care about different things, and dare I say, they have very different personalities. Excuse me. Thank you. It's been a joy. Our right human hemisphere is all about this present moment. It's all about right here, right now. Our right hemisphere, it thinks in pictures, and it learns kinesthetically through the movement of our bodies. Information in the form of energy streams in simultaneously through all of our sensory systems, and then it explodes into this enormous collage of what this present moment looks like, what this present moment smells like and tastes like, what it feels like, and what it sounds like. I am an energy being connected to the energy all around me through the consciousness of my right hemisphere. We are energy beings connected to one another through the consciousness of our right hemispheres as one human family. And right here, right now, we are brothers and sisters on this planet, here to make the world a better place. And in this moment, we are perfect, we are whole, and we are beautiful. My left hemisphere, our left hemisphere, is a very different place. Our left hemisphere thinks linearly and methodically. Our left hemisphere is all about the past, and it's all about the future. Our left hemisphere is designed to take that enormous collage of the present moment and start picking out details, and more details about those details. It then categorizes and organizes all that information, associates it with everything in the past we've ever learned, and projects into the future all of our possibilities. And our left hemisphere thinks in language. It's that ongoing brain chatter that connects me and my internal world to my external world. It's that little voice that says to me, hey, you got to remember to pick up bananas on your way home. I need them in the morning. It's that calculating intelligence that reminds me when I have to do my laundry. But perhaps most important, it's that little voice that says to me, I am. I am. And as soon as my left hemisphere says to me, I am, I become separate. I become a single, solid individual, separate from the energy flow around me and separate from you. And this is the portion of my brain that I lost on the morning of my stroke. On the morning of the stroke, I woke up to a pounding pain behind my left eye. And it was the kind of pain, caustic pain, that you get when you bite into ice cream. And it just gripped me, and then it released me. And then it just gripped me, and then it released me. And it was very unusual for me to ever experience any kind of pain, so I thought, okay, I'll just start my normal routine. So I got up and I jumped onto my cardia glider, which is a full body, full exercise machine. And I'm jamming away on this thing, and I'm realizing that my hands look like primitive claws grasping onto the bar. And I thought, that's very peculiar. And I looked down at my body, and I thought, whoa, I'm a weird-looking thing. And it was as though my consciousness had shifted away from my normal perception of reality, where I'm the person on the machine having the experience, to some esoteric space where I'm witnessing myself having this experience. And it was all very peculiar, and my headache was just getting worse. So I get off the machine, and I'm walking across my living room floor, and I realize that everything inside of my body has slowed way down. And every step is very rigid and very deliberate. There's no fluidity to my pace, and there's this constriction in my area of perception, so I'm just focused on internal systems. And I'm standing in my bathroom getting ready to step into the shower, and I could actually hear the dialogue inside of my body. I heard a little voice saying, okay, you muscles, you got to contract, and you muscles, you relax. And then I lost my balance, and I'm propped up against the wall. And I looked down at my arm, and I realized that I can no longer define the boundaries of my body. I can't define where I begin and where I end, because the atoms and the molecules of my arm blended with the atoms and molecules of the wall. And all I could detect was this energy. And I'm asking myself, what is wrong with me? What is going on? And in that moment, my brain chatter, my left hemisphere brain chatter, went totally silent. Just like someone took a remote control and pushed the mute button. Total silence. And at first I was shocked to find myself inside of a silent mind. But then I was immediately captivated by the magnificence of the energy around me. And because I could no longer identify the boundaries of my body, I felt enormous and expansive. I felt at one with all the energy that was, and it was beautiful there. And then all of a sudden, my left hemisphere comes back online, and it says to me, hey, we got a problem, we got to get some help. And I'm going, oh, I got a problem. So it's like, okay, I got a problem. But then I immediately drifted right back out into the consciousness, and I affectionately refer to this space as La La Land. But it was beautiful there. Imagine what it would be like to be totally disconnected from your brain chatter that connects you to the external world. So here I am in this space, and my job and any stress related to my job, it was gone. And I felt lighter in my body. And imagine all of the relationships in the external world and any stressors related to any of those, they were gone. And I felt this sense of peacefulness. And imagine what it would feel like to lose 37 years of emotional baggage. Oh, I felt euphoria. It was beautiful there. And then again, my left hemisphere comes online, and it says, hey, you've got to pay attention. We've got to get help. And I'm thinking, I got to get help. I got to focus. So I get out of the shower, and I'm mechanically dressed, and I'm walking around my apartment, and I'm thinking, I got to get to work. Can I drive? And in that moment, my right arm went totally paralyzed by my side. Then I realized, oh my gosh, I'm having a stroke. And then the next thing my brain says to me is, wow, this is so cool. How many brain scientists have the opportunity to study their own brain from the inside out? And then it crosses my mind, but I'm a very busy woman. I don't have time for a stroke. It's like, okay, I can't stop the stroke from happening, so I'll do this for a week or two, and then I'll get back to my routine. Okay, so I got to call help. I got to call work. I could remember the number at work. So I remembered in my office I had a business card with my number on it. So I go into my business room, and I pull out a 3-inch stack of business cards. And I'm looking at the card on top. And even though I could see clearly in my mind's eye what my business card looked like, I couldn't tell if this was my card or not, because all I could see were pixels. And the pixels of the words blended with the pixels of the background and the pixels of the symbols, and I just couldn't tell. And then I would wait for what I call a wave of clarity. And in that moment, I would be able to reattach to normal reality. And I could tell, that's not the card, that's not the card, that's not the card. It took me 45 minutes to get 1 inch down inside of that stack of cards. In the meantime, for 45 minutes, the hemorrhage is getting bigger in my left hemisphere. I do not understand numbers. I do not understand a telephone, but it's the only plan I have. So I take the phone pad and I put it right here. I take the business card, I put it right here, and I'm matching the shape of the squiggles on the card to the shape of the squiggles on the phone pad. But then I would drift back out into La La Land, and not remember if when I come back if I'd already dialed those numbers. So I had to wield my paralyzed arm like a stump and cover the numbers as I went along and push them so that as I would come back to normal reality, I'd be able to tell, yes, I've already dialed that number. Eventually, the whole number gets dialed, and I'm listening to the phone, and my colleague picks up the phone, and he says to me, "Roar, roar, roar." And I think to myself, oh my gosh, he sounds like a golden retriever. And so I say to him, clear in my mind, I say to him, this is Jill, I need help. And what comes out of my voice is, "Roar, roar, roar." And I think, oh my gosh, I sound like a golden retriever. So I didn't know that I couldn't speak or understand language until I tried. So he recognizes that I need help, and he gets me help. And a little while later, I'm riding in an ambulance from one hospital across Boston to Mass General Hospital, and I curl up into a little fetal ball. And just like a balloon, with the last bit of air just right out of the balloon, I just felt my energy lift, and I felt my spirit surrender. And in that moment, I knew that I was no longer the choreographer of my life, and either the doctors rescue my body and give me a second chance at life, or this was perhaps my moment of transition. When I woke later that afternoon, I was shocked to discover that I was still alive. When I felt my spirit surrender, I said goodbye to my life, and my mind was now suspended between two very opposite planes of reality. Stimulation coming in through my sensory systems felt like pure pain. Light burned my brain like wildfire, and sounds were so loud and chaotic that I could not pick a voice out from the background noise, and I just wanted to escape. Because I could not identify the position of my body in space, I felt enormous and expansive, like a genie just liberated from her bottle. And my spirit soared free like a great whale gliding through a sea of silent euphoria. Nirvana. I found nirvana. And I remember thinking there's no way I would ever be able to squeeze the enormousness of myself back inside this tiny little body. But then I realized, but I'm still alive. I'm still alive, and I have found nirvana. And if I have found nirvana and I'm still alive, then everyone who is alive can find nirvana. And I pictured a world filled with beautiful, peaceful, compassionate, loving people who knew that they could come to this space at any time, and that they could purposely choose to step to the right of their left hemispheres and find this peace. And then I realized what a tremendous gift this experience could be. What a stroke of insight this could be to how we live our lives. And it motivated me to recover. 2.5 weeks after the hemorrhage, the surgeons went in and they removed a blood clot the size of a golf ball that was pushing on my language centers. Here I am with my mama, who's a true angel in my life. It took me 8 years to completely recover. So, who are we? We are the life force power of the universe with manual dexterity and 2 cognitive minds. And we have the power to choose moment by moment who and how we want to be in the world. Right here, right now, I can step into the consciousness of my right hemisphere where I am the life force power of the universe. I am the life force power of the 50 trillion beautiful molecular geniuses that make up my form, at one with all that is. Or I can choose to step into the consciousness of my left hemisphere, where I become a single individual, a solid, separate from the flow, separate from you. I am Dr. Jill Bolte Taylor, intellectual, neuroanatomist. These are the we inside of me. Which would you choose? Which do you choose? And when? I believe that the more time we spend choosing to run the deep inner peace circuitry of our right hemispheres, the more peace we will project into the world, and the more peaceful our planet will be. And I thought that was an idea worth spreading. Thank you.
Yeah, huh? I'm an empath, and particularly when a woman is kind of choking up, I get choked up too. So that one always makes me cry a little bit after dozens and dozens of times watching this. What do you think of that? What are your thoughts after watching that? Yeah.
It just amazes me, like how she came to that moment of clarity.
Yeah.
Like while she was having a stroke, and even like while she was in recovery and stuff like